Hi friends, we'll be dealing on slope and deflection method of moment distribution. You can see from the little write-up I have here that in this moment distribution method, the basic assumption is that in the analysis of continuous beams and frames, all joints are assumed fixed at both ends of the span. This method can be used to analyze particularly indeterminate structures. In this moment distribution method, the rotation and translation of the joints are the unknown. All the end moments are expressed in terms of end rotations and translation. In order to satisfy the condition of equilibrium, the sum of the end moments acting on a rigid joint must be equal to 0. Using this equation of equilibrium, the unknown rotation at each joint is evaluated, and finally the end moments are computed. With the assumption that all end joints of a span is assumed fixed, this beam can be analyzed as follows. The rotation occurring at this end is 4ei theta sub a all over L, and the rotation occurring here is 2ei theta sub B all over L, and at this joint you have this, and this. It's actually a standard. Then where E is your modulus of elasticity, the sign here is deflection in the structure. That is actually this sign here is deflection in the structure. The rotation at the end of the structure is theta, which is this. And this, sorry, I didn't put this theta well, and this here and this. While I is the moment of inertia of the structure, and L is the length of the span, which is from A to B. Now, when you sum up the moment at each joint on the support, the four assumed rotation on the beam, you have that moment occurring at A, B, that's span A to B, we have 4ei theta A over L plus 2ei theta B over L plus 6ei phi all over L squared plus F sub AB. And on the same manner, you have the moment occurring at B here. Then recall that the stiffness factor, as we treated in Hardy-Cross method of a moment distribution, is moment of inertia all over length. Therefore, the moment occurring at joint A will be 2ek, 2ek, where k is L over I. So you remove this and this and substitute k. You have the moment to be equal to this expression, and the moment occurring at joint B to be equal to this expression here. I would like you to take this as a hint. Once there is no support rotation, either, you have that theta is equal to 0. Example: determine the support moment of the beam shown below. You can see from our Hardy-Cross method of a moment distribution, the question we have here is exactly the question we solve using the method of Hardy-Cross. So here we are going to solve it as well and see if our answers will be close, or they will be the same, or they will not be the same. This will justify the method we used before, and as well this method we are using here. So first, step 1, write down the fixed end moment of each joint, taking note of the sign convention, whereby you have that the clockwise moment is positive and the anti-clockwise is negative. So fixed end moments AB, we have A to B. The fixed end moment is minus QL squared over 12. You have this minus 180, just the same way we got it in a Hardy-Cross method of a moment distribution. That's just what you do around here. Therefore, this is the list of the fixed end moments according to each of the span we considered, or the joint either. Then we have the step 2. Write down the rigid moment equation of each joint. We already derived that before, but here you have to substitute the fixed end moment you already have from analysis of a fixed end moment. So till this point you already know what we have here. Then you get to your step 3. Take note of any special condition. You have that theta A is equal to 0. Why? No rotation at a fixed end. This is the reason. You have the deflection on the structure is 0, because the condition didn't tell us that there is sinking of support. Then you have that M moment at CB, that's the moment at support B, is 0, simply supported end. That's the reason that the moment there is 0. Now you get to step 4. You write down each of the rigid moment equation according to the conditions above. Since flexural rigidity is constant, then MAB is equal to theta B all over 3 minus 180. This is what I'm saying. Since the flexural rigidity is constant, that since EK is constant, you do your arithmetics around here, you get that your MAB is equal to theta B all over 3, using the special cases we got already. And one of the special cases, let me help you, is that this is 0 and this is 0. So it actually gets this off what we are considering. And 2EK, where K is I over L. So we substitute L into this formula and you end up getting what we have here as theta B over 3 minus 180 kilonewton meter. Then NBA, the same method. NBC, the same method. Actually, so I'll do this for you. And MCB, same method. So I'll do this to you. Let me throw light on MCB. Here you have, with this rigid moment equation, the EI, which is the flexural rigidity, is constant, so you get that out. You'll be left with 2K bracket of 2 theta C plus theta B minus 3 deflection all over L plus 109.3. Now from the special condition we have that this is 0. So since this is 0, the whole of this is now 0. Now here we have that EI is constant, so we are left with 2 over L, and BC, length BC, the span of BC is 5.5, so you have 2 all over 5.5 times 2 theta C, and that's where we got 4 theta C over 5.5. Then we have 2 all over 5.5 times theta B. That's where we have 2 theta sub B all over 5.5, then plus 109.3. So the same method, that's how all these ones will go to. Just do your normal arithmetics. It's mathematics. You do it, you get that. Now, step 5, apply the equation of continuity at the necessary joint. The equation of continuity will be such that theta B, which have both sides, it have side BA and side BC. This is what I'm saying here. It has side BA and side BC. So applying the equation of continuity around here, that sum of moments here is equal to 0. So you end up getting this MBA plus MBC is equal to 0. So we now sum the rigid moment equation. So we have it, add this with this, that's what we have here. 2 theta sub B all over 3 plus 180 plus 4 theta sub B all over 5.5 plus 2 theta sub C all over 5.5 minus 144.01. Here you end up getting this equation. When you get this equation, recall that MCB is equal to 0. That's the moment at point B, the joint C, is equal to 0. as the moment at this joint is equal to 0. Reason is simply supported. Now equate its own rigid moment equation to 0, as equate this to 0. So when you equate the whole of this to 0, you will have what we have here. So make theta c the subject of the formula, you will get this. When you make it the subject of the formula, you get this. Substitute that into what you already have in equation 1 that you formed yourself. So substitute theta c into equation 1, you have this. When you do your arithmetic well, you will get this. So from here now, you solve on to get theta b. So theta sub b will give you for 15.395 kilonewton meter. So from equation 2 that we have, that we formed here, sorry, this is supposed to be equation 2, that theta c is this, substitute theta b inside here, you get that theta c is 157.98475 kilonewton meter. I'm not approximating yet because I need the answer to look exact, like from the former procedure we followed. Now after that, since you've gotten your theta b and theta c, substitute it into the rigid moment equations, you will get m sub ab, which is moment occurring at point A to B, will give you minus 174.87 kilonewton meter, and that MBA will give you 190.263 kilonewton meter, and MCB will give you minus 190.263 kilonewton meter. This is where the equation of continuity works well. You know, we said that a moment about that point is 0. So if you actually sum the positive of this and the negative of this, it will give you the 0. Now MCB, if you substitute, you get 0 kilonewton meter. So drawing the bending moment diagram now of the support, you have this here, where support A gives you 174.87 kilonewton meter, and support B gives you 190.263 kilonewton meter, while support C gives you 0. So having looked into this and see that the values we got at this support and this support is same with that of Hardy-Cross method, I think the procedure is justified. Just follow it step by step, bit by bit, and diligently, accurately. I think you'll be able to get the answer you require. Thank you very much, and endeavor to watch the next video that will be coming up.